Polymers can interact with drug molecules through specific and non-specific interactions. Specific interactions are, for example, hydrogen bonds, and non-specific interactions would be hydrophobic interactions between drug molecules and polymers. And those specific and non-specific interaction, they basically increase the activation energy required for the nucleation step. And then a second effect, polymers can also hinder the reorganization of molecular clusters into ordered structures. And this also decreases the nucleation rate.
Dr. Ferdinand, you mentioned in your presentation that precipitation consists of two processes, nucleation and crystal growth. And you also said that polymers can be used to inhibit the nucleation and crystal growth rate. The effectiveness of the polymer depends on the properties of the drug molecule and the polymer. Could you perhaps explain more on the importance of structure-activity relationship?
Yeah. So in order to be able to act as a crystallization inhibitor, the polymer must interact with the drug molecule. And those interactions can be either specific or non-specific interactions. Non-specific interactions, for example, would be hydrophobic interactions. That means that the hydrophobicity of the polymer should be similar to that of the drug molecule. And specific interactions are hydrogen bonds or ionic interactions. That means that the polymer also needs some sites that can act as a hydrogen bond donor or acceptor. That's one point. On the other hand, the hydrophobicity of the polymer must not be too high, because if the hydrophobicity is too high, the polymer chains will interact with each other and not with the drug molecule. And the same holds true for the hydrophilicity. We need a certain hydrophilicity in order to have a polymer which dissolves after administration. But if the hydrophilicity is too high, the polymer will readily dissolve and not interact with the drug molecule at all. Yeah? But there's always this balance between hydrophilicity and hydrophobicity on the other hand.